Welcome everyone to episode 51 in our space shooter DevVenture. So by the end of our last live stream, we had just fixed the behaviors and the patterns and all of that. So in our testing seek behavior environment, in our testing seek behavior environment, we had reached a point where the enemy ship was able to attack and successfully defeat a target, and then once that was done, it was able to signal that it was done and get assigned a new pattern, right? And in that case, in the base case, it's just go to the next waypoint, right? But we also fixed the collisions of our testing seek behavior, so that when the enemy ship reaches a waypoint, it signals that it's reached the waypoint correctly and is able to be assigned a new random waypoint, and it then does the so-called what I call the ping pong effect, right? It goes ping and then pong to the next one, or it just reroutes, however you want to phrase it, right? So we just do a quick showcase of that. I can tell it to go to a random waypoint, off it goes, and once it reaches that waypoint, it immediately gets assigned another one and finds its way there, right? So that's cool. And one of the other cool things about this is I can also tell it to switch to attack pattern immediately, and it does that. It moves in and fires. Once that is destroyed, it moves on to a new waypoint, and everything flows and moves exactly as it should. And watch now, off it goes to the next one, and everything seems to work exactly as it's supposed to, and I'm very happy with this. So now the next step is to try and do flee, right? So we should be doing flee as the next behavior. So if you remember correctly, we did the seek behavior, we've done the shoot behavior, we've done arrival, and the next thing we need to work on is flee. So let me open up the tutorial for flee. It's the same one, flee and arrival. We've gone through it before, but I'm just going to do a quick revision, right? So it's basically seek, but the opposite. So instead of going towards your desired location or target, you move away from it. You increase the distance rather than decrease it. And we've spoken about this in our previous live streams, so you are welcome to go back and listen to it again. I don't want to keep repeating myself in new live streams for those who are following, and then I cause frustration with them. So for everybody's sake, it is on record in previous live streams, so you are welcome to go and consult those. Now, that doesn't mean that we shouldn't do a quick recap, right? So there's a difference between how does the flee behavior work and how are we going to apply it, but also there's a difference between going in super deep detail, going into super depth, as opposed to just doing a skim across the surface and do a brief revision session, right? So we've got our desired velocity. We normalize that by getting the difference of the vectors, right? So our target's location minus our current location position vector. We normalize that to get the direction, and then multiply that by max velocity to get the magnitude, so we have a full-on vector again. And then we influence steering, because this is all assigned into desired velocity. We then subtract our current velocity from the desired velocity, and we get our steering force. And so that's what you see here, right? So the flee behavior is literally just the opposite of that. So this was seek, and this is steer. my mistake, this is flee, right? So the flee behavior uses the same two forces, but they are adjusted to make the character run away from the target. So here is the resulting forces are calculated almost the same way as in seek. So this is actually flee. So what I showed you before was actually seek, and this is flee. Okay, so the desired velocity is position minus target rather than target minus position. So where am I? And then where is the target? Get the difference from where I am to where the target is. And that will be the opposite direction because it's a vector, it's not a scalar value. Then we normalize that to excuse me. We normalize that to get the direction, multiply that by the maximum velocity to get the magnitude of that vector, and then assign all of that into desired velocity. And then we set our steering as desired velocity, which is the velocity we want to have, minus current velocity, which is this velocity value, right? So that's the velocity we have at the moment. We take it out from desired velocity, and then we have our steering value. So the desired velocity in that case represents the easiest escaping route the character can use to run away from the target. The steering force makes the character abandon its current route, pushing it towards the direction of the desired velocity vector. Comparing the desired velocity vector of the flee behavior with the desired velocity vector of the seek behavior, the following relation can be established, that the flee desired behavior is literally just a negative of the seek desired behavior. Like I said, it's just the opposite of seek. So adding escape forces, and then we move on to arrival. We're not going to do that. So after the steering force is calculated, it must be added to the character's velocity vector, since that force is pushing the character away from the target. So every frame, the character will stop moving towards the target and start moving away from it, producing a flee path, which is the orange one, the orange curve, right? The addition of these forces and the final velocity position calculation are handled in the same way as before. Below is a demo showing several characters performing the flee behavior. So again, there are no embedded programs in this website anymore because the underlying software that was used to make them is no longer supported on modern browsers. So that's a bit disappointing, but what can you do? Every character is placed at the center of the following area with a random velocity, and they will try to flee from the target, or in this case the mouse cursor. The addition of all forces makes each character smoothly abandon its current route and flee the target. Currently the affected areas, currently the target affects every character, ignoring the distance from them. It could have been limited to an area of effect, where the character could flee only if it was close enough to the target. And that's our application, right? Once we reach a flee radius, once the character or the enemy actor gets close enough to our target, it needs to flee for self-preservation. Otherwise, it's going to crash into the target and bad things happen. So now we can think about adding obstacles, right? So there's waypoints, which are things that we want the enemy to seek out and go straight into, right? And then we've got obstacles. And in some cases, an object can be both a waypoint and an obstacle at the same time, like the player, right? So the enemy pirate is going to come towards the player, right? And seek it out in order to attack it. And if it gets too close, it's an obstacle, because if it collides with the player, it's going to cause damage to the pirate and the player, and the self-preservation algorithm is going to prevent that, and so it wants to avoid an obstacle, right? But then you've got just pure obstacles like asteroids. For an enemy pirate that can't mine asteroids, they are just obstacles, right? So let's get into this. I'm going to check what is this thread called again. This is operational layer, combat logic, and combat system implementation. Okay, good. So Do we have a thread for navigation or behaviors? Tactical layer, task delegation, operational layer, integration, playable, scene assembly. We don't. I just want to check something. Did we have another operational layer? Just before this. Please create the threads you recommended in your operational inventory management table. Show me all the operational layer threads you have in your inventory. AI programming, pattern signals, and behavior management. AI behavior management, pattern signal design and propagation across strategic, tactical, operational layers. Design and implement pattern signal handling, behavior selection, switching, and documentation of integration points for a modular AI system. I see. So we've been using the combat logic thread to do the AI programming threads work. That's a bit disappointing. Do you remember whether we initialized the AI programming thread? I don't see. Hang on. Maybe it wasn't shared with the entire group. Operational. Yeah, it wasn't. So let's share that with the thread space. There it is. No, there it isn't. There it is. Okay. So over here, I'm going to go to the other thread, this operational combat one, and I'm going to tell it to share all of its information with the other thread because we are bleeding over. Remember, we said that threads in the operational layer can communicate with each other, right? So we said that here layers are horizontal or vertical, layers talk to adjacent layers, and layers can have many threads. And another thing we said was that any thread inside the same layer can communicate with its neighbors because they are adjacent, right? They are within the same layer. So here is the brief of the brief about your neighbor thread. I mistakenly used you to do some of the work that was meant for the aforementioned thread. Please check this entire thread and catch up your neighbor with all the relevant work we've done here that is meant to be there instead. So the work done here that belongs in the operational layer, AI programming, pattern signals, and behavior management thread falls into 4 main areas: pattern signaling, behavior sequencing, concrete behaviors, and event or waypoint handling. So pattern signals and data contract. Defined an enemy shop controller that owns the pattern, standardized the AI pattern signal or the pattern signal API, established the parameter contract. All pattern entry points now emit using this contract, and then the tactical operational bridge, the behavior implementations, and waypoint event signaling, and then behavior and the behavior of pattern switching. This is the core work that should be handled over to the operational layer, AI programming, pattern signals, and behavior management thread, a working pattern signaling contract, a per ship behavior sequencer, concrete behavior implementations, and waypoint or event hooks feeding into the pattern system. So I'm going to copy this entire response. Then I'm going to go over to that thread, which is this one, and then I'll post a prompt here. So I've been doing your work in a neighboring thread by mistake. Here is the work I need to catch up with. I need to catch you up on so we can resume our work here instead. Feel free to ask me questions or request code to help fill in the missing context for yourself. This work clearly belongs in the AI operational programming thread and can be adopted as is, the only minor clarifications and some naming contract tightening for milestone 1. Pattern signals and contract. The pattern signal API and parameter contract are solid for operational use and give the tactical or strategic layers a clean surface. So enemy ship controller owns a patterns dictionary and is the authoritative source of pattern definitions per ship type. Signals are standardized as pattern assigned or pattern cancelled with their various arguments. The parameters contract for multi-step patterns. So there's pattern name string and behavior sequence array of strings. This typically the patterns at pattern name.duplicate plus shared targeting info such as target node path, and target position, all used by all behaviors in the sequence. All pattern entry points now emit with this contract. Attack test, waypoint movement, find waypoint with seek, plus waypoint position / node path. One open question for you. Is the intent that tactical always passes a full behavior sequence, or should enemy ship controller be allowed to derive it from pattern name if missing? That's a very interesting question, and I don't fully understand it. So I'm going to have to ask for some clarification before I can answer it properly. But let's carry on reading, and then we'll get back to that question, okay? NPC Behavior Manager Sequencing. The per ship type NPC Behavior Manager is correctly acting as the operational orchestrator and the bridge between pattern signals and behavior nodes. So the core state, current pattern, current behavior, available behaviors. They are all keyed by behavior name without behavior underscore, which is lowercase. And then current sequence is an array of strings. The sequence index is an integer, shared parameters dictionary for all behaviors in the attack pattern. And then pattern level signals from the manager, pattern completed, pattern failed, pattern interrupted, or ready for a new pattern, right? So ready for pattern. As the I'm idle hook back up the stack. Then you've got an assignment flow. On pattern assigned, filters by enemy ship ID, cancels any current pattern via cancel current pattern, and sets the current pattern and the shared parameters. Extracts current sequence, is assigned parameters.get behavior sequence with an empty array, fails with no behavior sequence if empty, and then calls start next behavior from sequence index equals 0. The start next behavior either emits pattern completed when the sequence is exhausted, or resolves the next behavior by behavior key is equal to current sequence index dot to lower. This looks it up in available behaviors and calls current behavior dot activate, enemy ship ID, and shared parameters. Missing behaviors cause pattern failed and state clear. And then there's cancellations, behavior completions. We know all of this already. We've gone through it a few times over many live streams. So this is literally just catching this thread up with all the data that's come before, right? I'm just checking to see, are there any questions it has for me, or are there any code requests it has for me? And then I'll provide those answers / codes, right? So it kind of figured out all of this from the other thread. Key behavioral property pattern switching is now clean because new assignments always go through cancel current pattern, preventing shoot, seek, arrival, contention. Then we have the concrete behaviors seek, shoot, arrival. The three behaviors fit the contract and give a good baseline for milestone 1 patterns. So seek and shoot, arrival. So one detail to confirm. Do you want arrival to have an optional timeout or a maximum distance fail condition so that patterns can terminate if the target becomes unreachable? Good question. So we'll come back to that again. So there are currently 2 questions we need to answer. 2. And we'll see if there are any more, and then we'll answer those afterwards, right? So waypoints and event pattern wiring. The waypoint event side correctly lives in the operational layer as the bridge from world events to pattern assignments. Type waypoint nodes, enemy ship controller responses. This completes the event pattern behavior chain for operational logic. Then we've got pattern switching. So the overlapping pattern bug is correctly fixed at the operational level. Previously, new patterns could start while the old behavior was still active, causing seek/arrival and shoot to fight over movement and orientation. Now, on pattern assigned, always calls cancel current pattern first, which deactivates the current behavior, emits pattern interrupted, and resets all pattern state before starting the new sequence. To move forward in this thread, it would help to see the current GD script signatures for type npc behavior manager.activate/deactivate on each behavior node, so the contracts can be documented formally, and the exact signatures you are using for behavior completed and how they are connected to the manager. Once those are shared, the next steps here can be formalizing a brief pattern and behavior contract documentation file for milestone 1 page, suitable for tactical or strategic combat logic threads, and adding 2 to 3 focused unit/integration test scenarios. Attack interrupted by find waypoint, missing behavior in sequence, moving waypoint, and arrival. Okay, so it's requesting some code. It's asked 2 questions, and it's requested two things from the body of code, right? Now, I'm just going to give it the GD script files and tell it, look, you have your questions, you can find your answers. And then in terms of the questions, let's go back to them and find out how to answer them, right? So one question for you, here's the first one. Is the intent that tactical always passes a full behavior sequence? Or should enemy ship controller be allowed to derive it from pattern name if missing? I don't fully understand your question. Please clarify what you mean by full behavior sequence and derive it from pattern name. Okay. So here, the full behavior sequence and derive it from pattern name are about who decides the concrete list of behaviors that will run and where that list is built. What full behavior sequence means, by full behavior sequence here, the idea is the behavior sequence parameter is an explicit ordered list of behavior names, for example, seek, arrival, shoot, flee. Full just means the entire list of behaviors that make up this pattern in the order they should be executed, not just the pattern name. So the question is, when someone assigns a pattern, do they always send that full list down like parameters is this? What derive it from pattern name means. Enemy ship controller already has an internal patterns dictionary like this. Derive it from pattern name means that the tactical layer would only send the pattern name and maybe target info like pattern name attack, no behavior sequence key. Enemy ship controller then looks up the behavior list itself from its patterns dictionary and fills in behavior sequence before emitting the pattern signal to NPC behavior manager. In other words, option A, the tactical always sends the full behavior sequence as part of the parameters, and option B, the tactical only sends the pattern name, and enemy ship controller looks up patterns at pattern name and sets behavior sequence for the manager. If you tell how you want tactical to work, the contract for this thread can be nailed down around one of those 2 options. Oh, okay. I think I like option B more. Would you like to see the script files of the tactical layer of the strategic and tactical layers so you can get a better understanding of which option fits better with the existing implementation. Okay, so yes, seeing the strategic and tactical layer scripts would be very helpful, especially around how they currently choose and assign patterns to ships. If you're comfortable, then sharing the following would be enough. The tactical layer class that issues orders to individual ships or groups, any functions that call into pattern assignment or AI control, and the strategic class that defines high-level goals or missions and how it delegates them down. Once that is visible, the pattern contract can be tuned so that tactical or strategic mostly say pattern name attack plus target or context, and enemy ship controller is the canonical place that maps that to arrival, shoot, and flee, with the option to later add advanced calls that let tactical override behavior sequence when needed. Okay, so here is the the strategic script file called enemy ship controller.gd. Oh no, I clicked on the wrong thing. In the script file, enemy ship controller is this one. Copy everything, paste. And here is the tactical layer script file called NPC behavior manager.gd. And that would be this one. Please have a look and tell me which of the options will fit best if neither option fits currently. Option B fits your current implementation best, and you are already 90% of the way there. Only small adjustments are needed to make it the default contract. If enemyshipcontroller.gd, or rather in enemyshipcontroller.gd, every place that assigns a pattern is already looking up the pattern locally and building behavior sequence from the patterns dictionary. Here's the evidence for that. And then in type npc behavior manager.gd, the tactical operational manager simply expects whatever is in parameters.behavior sequence. The sequences behaviors, or rather and sequences behaviors from it without knowing about patterns at all. Excuse me. So right now, enemy ship controller is the canonical owner of the pattern library, and NPC behavior manager is a pure sequencer that only cares about the behavior sequence and parameters. This is exactly the shape for option B. Interpreting option B with your scripts. With option B, the strategic or tactical picks a pattern name and optional context. Enemy ship controller uses its patterns or patterns dictionary to derive the concrete behavior sequence from pattern name before emitting the signal down to NPC behavior manager. And then NPC behavior manager only ever sees behavior sequence. It does not need to know how the list was chosen. Your current code already behaves this way logically. Tactical never overrides the sequence. It always duplicates from the controller's patterns dictionary. If you want to lean fully into option B, excuse me, as the official contract for milestone 1, you can treat patterns in enemy ship controller as the single source of truth for pattern definitions. Keep NPC behavior manager free of any knowledge of patterns, only behavior sequence and shared parameters. The only further refinement to consider later, not required now, is adding a convenience API in enemy ship controller like assign pattern to enemy that always does the sequence lookup and emit in one place, so other systems never handcraft behavior sequences themselves. Okay, so that's good. Have I answered your other questions or context concerns by sharing the full script files? Do you need any other information? The full strategic and tactical scripts answer the earlier questions and give enough context to proceed with option B as the working contract. What would still be useful, not strictly required, but helpful later for robustness. Behavior node APIs, the exact activate signatures and behavior completed signal definition on seek, shoot, and arrival to document the operational behavior contract formally, and any planned future patterns like patrol, regroup, evasive, so the pattern sequence contract can be checked against those designs early. If you are happy with option B, the next concrete step in this thread could be to extract short pattern and behavior contract documents from this code so future features and threads can plug into it without ambiguity. Okay, so then I'll say, all right, I'll share all current behavior files, i.e. the operational layer, with you, so you have the full AI architecture context. Here is seek, behavior seek.gd. So now we go up to behavior seek, copy all, and paste it there. Here is behavior arrival. Okay, let's find it. There it is. Copy everything, paste it there. Here is behavior shoot.gd. Over here, copy everything and paste it there. Let's see, behavior arrival, seek, and shoot. So that's behavior seek.gd, behavior arrival.gd. Okay. Does this answer your questions? Do you need any more information? Yes, this answers the earlier questions about behavior contracts and gives enough context to lock in how the operational layer should behave for milestone 1. What is now fully clear is the behavior API. All behaviors expose a consistent interface, the completion signal. Each behavior emits the same signature, and the parameter contract. Targeting behaviors consistently accept target position, target node, or target node path, and resolve them into working positions or nodes internally. Shared parameters. The parameters dictionary passed from MPC Behavior Manager is treated as shared, not per behavior, which matches the idea of pattern level parameters. So no more required information for now. For the operational layer, AI programming, pattern signals, and behavior management thread, the current information is sufficient to formalize the pattern and behavior contract. Add unit integration tests around seek, arrival, shoot sequencing, and pattern switching, and refine the edge cases without needing more architectural context. If you later introduce new behaviors like flee, patrol, or add new pattern types, then sharing these behavior scripts when they exist will help extend the contract cleanly, but nothing else is needed right now. Okay. Perfect. Now, what is the next step for us? The next step is to formalize and tighten the contract between strategic, tactical, and operational layers so you can safely build more patterns and behaviors on top of it. Lock in option B in the code. Right now, you always construct behavior sequence from patterns manually in Enemy Ship Controller. To make option B explicit and dry, as in the dry principle, like do not repeat yourself, right? Add a helper on Enemy Ship Controller. For example, assign pattern to enemy. Then you replace all the direct pattern assigned .emit calls with this new function, plus extra parameters like the waypoint target or attack target. That makes Enemy Ship Controller the single source of truth for how pattern name to behavior sequence is derived. Write the pattern and behavior contract in a short document. So you codify what you already implemented so other threads don't accidentally break it. Signals required. Hi, welcome to the live stream. Yeah, so we're just currently going through catching up with one of the threads on Perplexity with the work we did in another thread. Codify what you already implemented so other threads don't accidentally break it. So the signals, the required parameter keys, behavior guarantees, and this can live as a short markdown or a comment block referenced by strategic tactical combat logic threads. I think we'll probably make that as a markdown and keep that in our project file, project folder. And then step 3, add 2 to 3 focused tests or scenarios and use your existing test hooks as the foundation. So the attack pattern, happy path, pattern interruption, and the failure path. If you like, the next thing here can be pick one of those scenarios and work step by step through how to instrument or log it so you can visually confirm the pattern behavior flow in Engine. Okay, let's do step 1 first. Let's do step 1 first. You already have the script file in context, so give me the instructions on where to make the changes, so I don't cause unnecessary bugs. Okay, so I've got the instructions here. I'm going to put this to one side and we will make those changes here in the script file. Okay, so I'm just going to go into the enemy ship controller file, which is this one. We create a new function close to the top. So that's ready, and that's input, move enemy to random waypoint. So we'll just do this here instead. Okay. Yes, it does. It's very similar to Python. It isn't actually Python, but it's designed to look very similar to it. It's actually written underneath using C++. So we want to create a function. Function assign pattern to enemy. For now, we'll just say pass because we need to handle all of these parameters. So we're taking in the enemy ship ID. As an integer. Then we've got pattern name. That's a string. And we've got extra parameters, which is a dictionary. And we'll assign that to be an empty dictionary for now. Okay, and then in pass, we'll change this to if not patterns dot has pattern name, then we push an error and return. I'll fill those in now. If not patterns has pattern name, then push an error saying enemy ship controller unknown pattern plus plus pattern name and then plus that. I will just leave the full stop, and then we call return. Otherwise, we do this. We say variable parameters is a dictionary, and that is assigned a dictionary. So we'll do the following. So I just want to check this column is 40 and the assignment column is 50. So move that to 40 and move that to 60. It should actually be 60. And then we'll move this one over there, and we'll just tab these out. Okay, so we want to give it pattern name and pattern name. And then behavior sequence. and that would be patterns at pattern name dot duplicate. Patterns. Okay, so that's fine. And then after that, we have to do merge. Oh, that's a comment, my mistake. We'll say parameters dot merge extra. That's a good question. I only see it now, my mistake. If you messaged a little while ago and I ignored it, it's only because I only see it now. I prefer Godot over Unity mostly because it's simpler. It's so much simpler. It's not simpler as in more like that Unity is more difficult. It's just that there's so much going on in Unity, and they're all separate, like separate subsystems, and they're all like all over the place. Whereas Godot is all unified, and everything is just like basically one way to do things most of the time, and it's easier to think of in like the way that you think about Godot engine. You think about things as either a node or a scene, and everything is just it's not the entity component system, you know, the ECS, where everything's an entity and it has components and object orientation and stuff. Like you can get object orientation in Godot engine, right? But the way that it does it is so much simpler, right? So you create a scene, and then once you've done that scene, it becomes a node, and you can use that node in another scene. And so that's how you build up your so-called ECS. And it's so much nicer. And then also like GDScript compared to C# is also just easier to think in. It's not so much code. You don't have to write as much code to do the same things with GDScript as you would with C#. And then also it's just again, and then the other benefits, of course, is that it's free, it's open source. You don't have to pay any licenses or any royalty fees or any of those kind of things. Those are the main reasons I've chosen Godot engine. And the reasons I've stayed with Godot engine were the ones I listed afterwards. I mean, before, right? So the simplicity and all of those things are the reasons I stayed. Extra parameters. So hopefully, I hope that answers your question. Extra parameters and true. What? Where is parameters? Variable parameters. Oh, I see. It's an indentation error. Should be like that. And then pattern assign.emit. Yeah. Pattern assigned.emit. Yeah, so I used to use Unity back in the day when I was doing my my undergrad degree in computer science and game development. I had to use Unity. That was part of the course requirements. And then when I did my honors, I also used Unity. And after that, I also tried to use Unity again. But Unity keeps changing. Also, that's one of the reasons why I wasn't very happy with Unity. They keep changing all kinds of like underlying systems and stuff, and new versions of Unity are like vastly different to previous versions, and it's just hard to catch up or to keep up with all of the major changes that they make. It's not like small changes or feature additions. It's like huge fundamental changes that they made, like adding new render pipelines and the dots framework and all of this stuff. So I was like, you know what? I'm just gonna when I found out about Godot Engine, I'm like, okay, look, let me find out if I even like Godot Engine. And once I found out I liked Godot Engine, I was like, I'm not going back to Unity. If I do take on a high, a more high fidelity engine, I would probably choose Unreal, to be honest. But again, this is all my opinion, right? So just take that with a pinch of salt. Pattern assigned .emit the enemy ship ID and pattern name and the parameters dictionary. Okay, so we have about 5 minutes before the live stream is done. So I'm going to take this chance to... Oh, that's cool. Yeah. So I did my undergrad in computer science and game development, and then I did my honors and masters in computer science after that. But my passion has always been game development, so that's the field I chose at the end. After my masters, I'm like, okay, look, I'm going to take my expertise and just push it towards game development. So I'm going to take this opportunity now, before I wrap things up, to thank our junior DevVenturer, Cubes. Thank you so much. He's a supporter. He's a supporter on Coffee. So you guys are welcome to check out coffee.com/mtkdev. That's the link here at the bottom. It's also in the description of the video. And you can join my Discord server community as well. The link is in the description there too. So with that being said, let's just quickly finish this bit, and then I can wrap things up. So step 2, update the waypoint related pattern assignments. So still in the enemy ship controller. So for those who are wondering, I'm following a step-by-step guide that I got Perplexity to help me with. Thanks so much. I hope to see you in future live streams too. So update the waypoint related pattern assignments. So this is the next thing we're working on. And again, like I mentioned before, I'll be doing this in between live streams as well. So by the time we get to our next live stream, which is tomorrow, the same time, then I will probably just continue where I left off, which will be a little bit ahead of where I am now, because I'll be finishing off all these steps in the background, and then we'll probably start on something new in the next live stream. Oh, that's cool. You can, if you join my Discord server, you can send me the link, and then maybe not maybe, then I'll check it out. We can support each other. Yeah, so okay, I think I'll do that. I'll work on this after the live stream. But for now, I'm gonna wrap things up, right? So like I mentioned, there's Coffee. My Coffee page has 3 membership tiers. It's got the intern, junior, and senior DevVenturers, and the perks are listed on the Coffee page. Each one will give you a specific role on the Discord server, so you'll have access to categories on the server that have their own channels, and those are all role restricted, so you won't be able to access those things without having those roles, right? So that's one of the perks, and then there are others. If you don't want to do monthly donations, you can also do one-time donations on Coffee. So, that's something to consider. And then also, besides that, you could support the channel by liking, subscribing, sharing these videos with others, and commenting, so engaging with the content and the community also helps a lot. So just let YouTube know that these videos are popular, basically. that is just as valuable as donations. Because if you can't afford to donate and you share the video, then maybe someone you share it to can donate. So that also supports the channel, you know what I mean? But yeah, thank you so much for your time and your attention. I'm going to sign off now, so I'll see you in the next live stream.